Hi and welcome back to a new video, and today maybe also a more extreme video. Well, not in regard of extreme cooling, we're not doing LN2OC. It's going a little bit in the extreme direction with the updated version of the EK Tech cooler, which we have right here. We have a very extreme memory kit. Obviously, we're going to take a look at this further more in detail in a second, and also about the best CPU and mainboard combination you can possibly get for a C590. Even though C590 might already be at close to the end of its life, that's probably also the time where you can find the best boards and the best memories and probably also the best cooler combination available. The first main decision will be the platform, aka the motherboard. And there we basically have three choices, starting off with the ASUS C590 Apex. You know this board from me because I used it several times before, pretty happy with the board. The main and the most positive aspects about this board is, first of all, availability, second, price, because you can basically get this everywhere if you want to. Second choice would be the C590 Tachyon from Gigabyte, the board which we're going to use in today's video. Definitely one of the best boards for C590 available, if it's available. The third option would be the C590 Dark from EVGA. Unfortunately, I don't have this board, so I cannot put it here on the table, but it doesn't matter anyway, because we're focusing on the Tachyon from Gigabyte today.
Seasonic, the heart of your system.
Just by looking at the C590 Tachyon from Gigabyte the first time, you will already notice that this is a board you cannot compare with your average C590 board. As I said before, it's somehow comparable to the C590 Dark from EVGA and also the C590 Apex from ASUS. Starting off with the VRM of the board, we have 11 phases just for CPU V-Core. Those are 100 amps power stages for the CPU, which is in the end just still a marketing number. But I can tell you from my testing that no matter what you're going to do, if it's LN2OC, if it's 24/7 OC with water hardcore, this VRM will be sufficient for everything you will try. You have dual 8-pin EPS connectors, which will go to the CPU voltage supply. And yeah, I mean, for average testing or for like pre-testing, even for moderate overclocking on air, water, whatever, only one 8-pin EPS is absolutely sufficient. But if you go for like very hardcore OC, you should definitely consider to populate both. Both are also using solid pins, which will be better for contact, which allows to handle more current on the connector itself. Obviously, it's a 1 DIMM per channel motherboard, which allows best signaling quality for the memory to the CPU. 1 DIMM per channel allows the memory slots to sit closer to the CPU and you have less interference, which is great. But then in the end, it also allows only to use 2 memory sticks. We will have a very good memory kit, which we're going to test obviously in today's video. If you were lucky enough to grab one of these for your daily use, then the I/O area might be relevant to you. First of all, we have Wi-Fi, we have Ethernet, we have one USB Type-A here, USB Type-C, 6x USB Type-A, HDMI in case you want to use the iGPU, and we also have PS2. In order, if you want to run Windows XP, you have dual PS2 for mouse and keyboard. On top, we have 2 buttons which might be relevant also for you for OC. Well, the right one, the Q-Flash button, you might already be aware of, and that's also not that much OC relevant. It's just very handy if you want to flash your BIOS without the CPU being present in the slot, or if something went wrong in the previous flashing attempt, then just plug in the USB in the back and then you can use this to flash your BIOS. And then we also have the OC ignition switch right here. I remember very well that the OC ignition switch already led to a lot of support requests for average users. Back then, I think it was C97 when the OC ignition switch was already present. And it sometimes happened that people accidentally pressed the button maybe during system assembly, and this basically cuts off the power supply for the board. It will look like your system is still running because the PSU will still be switched on, but your CPU is cut off from power. And that's very helpful for LN2 debugging. It's helpful for a lot of reasons. For example, if you run LN2 at very low temperatures, sometimes it's just happening that your CPU doesn't like the temperature, you have to heat up. And at the same time, you usually want to have fans sitting around your CPU LN2 container, which is blowing up air. Basically, it's trying to remove the cold air from the board, trying that the cold air will not go down on your board, causing a lot of condensation, causing a lot of ice building up. And if you have any issue and your mainboard is shutting down, usually your fans are also shutting down. And if you need more time for debugging or working on your system in the meantime, then you can just push the OC ignition button and your PSU will still run. it will cause your fans to spin and you have more time for debugging and less hassle with condensation, ice building up. At the same time, a lot of people are, for example, also using heating elements. Elmore is selling those kind of heating elements. If you want to check out Elmore Labs shop, then you will know what I'm talking about. So those are heating elements you can, for example, put behind your GPU, behind your mainboard socket. And those heating elements are basically heating the backside of your PCB for less condensation and less ice building up. If you hook up this heating element to your normal PSU, if there is an issue, your system is shutting down, the heater is also shutting down. So you can either hook up the heater to a second PSU you have sitting next to it, or you use the OC ignition switch and keep the heater element running while you're debugging. Before we continue with today's video, please take a minute and consider subscribing to our second channel, because this will be the second last video here on this channel in English, and every further English video will be published on the second channel. One more thing that sets apart the Tachyon from everything else is this entire area right here. First of all, starting off with the Sata Ports, which are in a very weird location if you just look at this from a PC building perspective. But these Sata Ports are connected to, this should be the SATA controller. Yeah, this should be it. And this SATA controller is Windows XP compatible, which the rest of the SATA ports down there, which are connected to the chipset, they are not compatible to Windows XP. But some of the benchmarks on HWBot you still want to run on Windows XP, and that's where you can use those SATA ports for. Some words regarding the buttons, which might also be very handy, especially for LN2 OC. Well, first of all, start button, not much to add to that. Reset button, also very clear. Then we have, well, the clear Cmos button, which clears your BIOS if something went completely wrong and you will not be able to fix it. For example, with the safe mode, because if you're stuck during boot and you do not want to lose your BIOS settings, you press the Gigabyte calls this limp mode. You might be familiar with this from Asus. They call it safe mode. It's basically the same thing. Then the reset switch, and then there is also the retry button. So if you just want to reapply your BIOS settings and try if it works a second or third time, then you hit the retry button. Obviously, we have a ton of measurement points for like vCore, VDIM, PCH, whatever. Then we have some additional buttons. Those are for adjusting the CPU ratio. And I have to add, like, judging from the past, at least I didn't try this on the Tachyon so far, but in the past those never worked. Or you had to install some weird software which often also wasn't working, so maybe I have to still try that. At least A and B are very helpful. You can use those to store different BIOS presets on A or B. Basically, if you restore your BIOS with the clear Cmos button, you can then press A or B to load up a BIOS profile before you enter BIOS. The A and B buttons, for example, might be very helpful if you change your outside conditions. So for example, you spent 2 days debugging your memory, you found the best and the perfect stable running memory settings, and then you want to start extreme overclocking. It might not even be LN2 overclocking, it could also be dry ice, or you're just running a chiller at minus, I don't know, 10 degrees Celsius. This already changes how the CPU behaves, how the memory controller behaves, and sometimes you need to have different voltages just to make sure that your system is booting up. This is also why you typically have the LN2 mode, which is also present on one of those bottom switches. Then you flip the LN2 mode switch, which is applying additional voltages to the CPU, which helps the CPU to boot up even at like minus 160 degrees Celsius. And that's the same what you can do with the A and B switches. You can load up your own definition first, like raised voltages, whatever voltages that might be. And then you hit the A and B button, load up your profile, and this might help you debugging, might help you to boot your system in a better way. And that's also the reason why you typically have the retry button, and that's not only related to the Tachyon board, but also the Apex board and everything else that comes with the retry button. It's typically because you maybe figured out some settings on like ambient temperature, and then you're cooling down and things don't work anymore. And then it could be that your memory controller behaves worse or behaves better on lower temperature, and that's something you can debug with the retry button. So for example, you try to apply a setting which is too much for the memory controller, and you're maybe sitting at minus 40 degrees Celsius, and then you're cooling down in like 10 degrees Celsius steps, and every 10 degrees Celsius you're trying the retry button, see if things improve. And then at a certain temperature you maybe figured out, hey, at minus 120 things are working again because the memory controller is cold enough. And that might apply to even like the core or like the cache, whatever. That's what you can do with the retry button. Now let's go over to this very impressive memory kit, which is a Trident C Royale Elite kit. 4000 MHz C14 32 GB dual channel kit. So this kit seems like it's the final breath of what you can squeeze out of the B-die ICs. At least it's a very strong bin from G.Skill. 4000 MHz C14. Might also be the best combination for either Intel or AMD. It doesn't matter much because both of the desktop platforms have this region between 3600 and 4000 megahertz, where you have this change within the memory controller. For Intel, it's changing between gear 1 ratio and gear 2 ratio. And for AMD, it's running with the linked and unlinked mode. Both are roughly between 3600 and 4000 megahertz. So up to 4000 megahertz, if you're happy enough to have a very strong memory controller, then you can utilize the full speed of 4000 megahertz C14. And for example, if you can only maintain to run like 3800, 3733 maybe, then you can just run even tighter timings. But overall, that is a very, very impressive bin. When it comes to the design, I mean, that's just subjective. I'm not that much a fan of this like clear diamond thing on top, but some people like it, some people don't. Obviously, our 11900K will also need sufficient cooling because you know those things consume a lot of power and tend to run hot. That's why we have this autofocus friendly packaging, which is entirely black from EK, but you can read it EK QuantumX Delta Tech Cooler. We already featured the Tech Cooler once, but that is an upgraded version with an improved and stronger Peltier element, tech element. I'm not going over every detail again because we already featured this cooler in a previous, more detailed video, but basically it's a tech water block, which means that, I mean, first of all, it's a water block with a ton of surface area inside, which is required because there is a tech element sitting inside. You can also see there's a power cable. So it requires additional power to run the block. And there is a temperature sensor. Actually, if we turn this around, if we try to take off this foam, well, it's kind of difficult to remove this, like, I don't know, silicone like gasket thing. Anyway, this part is to seal off the cooler from the mainboard, basically to prevent or minimize occurring condensation, because this area right here can reach lower temperatures than ambient. And that's due to the Peltier element, the tech element, which is sitting like right in this thing right here. So between the copper plate right there and the copper plate on the bottom, you can see this strangely structured thing sitting in between. That is the tech, and the tech allows the block to reach, well, in theory, lower temperature than ambient on this surface area to cool the CPU. Then we have the typical accessories for mounting. We have some additional foam for the backplate. And then we have all the electronics to regulate the tech. First of all, this goes to the PSU for power supply of the tech and the whole controller right here. You hook up the controller to this right here, and then there's the temperature sensor going there. The reason why you would typically mount this right on top of your block is that the dew point regulation will be as accurate as possible, because this allows to run colder than ambient but just right above the dew point, which allows to run colder than ambient but without condensation. And this regulation is only possible if this is like sitting as close as possible to the warm source. But if you put this, for example, behind the mainboard tray where you would have colder temperatures, then the dew point regulation might be affected and might not be as accurate. All right, going to assemble everything and then we will be back. One thing that's also quite unusual about this board is, well, first of all, if you take a look at this from a mechanical point of view, you will have 4x16 mechanical slots. But if you check the electrical wiring to the slots, the first one is only X4. And it's also quite unusual that the top one is connected to the chipset, which is, it's just an extreme overclocking thing. Typically, if you just run 2D benchmarks like Cinebench, SuperPi, whatever, you would hook up your like small VGA to the chipset, which makes benching a bit easier. And that's what we're going to do, to put it there, to the top slot with X4. Otherwise, CPU, cooler, memory kit, everything is mounted. The only thing which is still trash about this water block is that the USB port is just on top, like right in your face. If you mount this in your system, this will not look nice. The rest of the connectors on the side is okay, but this on top is not good. Everything assembled, and as you can see, it's also running. I started off with some reference runs with ADA64 and Cinebench R20. Everything is pretty much stock. I mean, just loaded the XMP profile with 4000 C14, which is, I think, already quite impressive. And just judging by the clocks of the CPU, you can see that this is basically running stock. but it's also good to see that we can see 5.3 GHz boost consistently, ADA64, 62,000 in read and write, which is already quite impressive for just loading XMP profile and keeping everything else stock. Judging by the temperature in hardware info, you can also see that the cryo cooler works well. At least at some point we also had a core temperature of 0 degrees Celsius, which is quite good. Maximum, however, was 82 degrees Celsius on stock. So I'm not sure how much headroom there will be once we do manual OC across all cores. And the first reference run on R20 was 5800 points, which I think is a bit low, but considering that there was still a lot going on in the background, should be kind of okay. You can absolutely tell that this updated version of the EK cryo cooler or EK Quantum CPU block is definitely an improved version over the previous one. I mean, if we look at CPU package power draw during the Cinebench R20 run, it is 300 watt continuous load. I mean, obviously the temperatures are not great. I mean, it's still like 86, 87, 88 degrees Celsius, and the peak, that was from the German video, 93 degrees Celsius was the highest we had in the previous run. But still, that is a very, very high power draw. I'm very curious to see what kind of temperatures we will achieve during gaming load. For now, the CPU is manually overclocked to 5 GHz across all cores, which you can see. And the memory kit is manually overclocked to 4400 C14, daily stable. And that's almost 6200 points. Those are the settings I used so far. I'm going to increase CPU clock to 5.1 to see if that will work out. 5.2 definitely did not work out, so it's not a great CPU, but I mean, that's just gambling and bad luck in this case. The memory is clocked to 4400 megahertz. I mean, 4400 C14, which we can see if we go to the memory timings. Can take a look at the timings which are set and also all the sub-timings which are set. A lot of people always ask me how to do this. In the end, the easiest way is to just set everything manually and try to put them as low as possible, compare read and write rates in ADA64, see what's affected, see what's stable and not. But you can probably use this as guidance if you have a very similar kit. Try to reproduce this, maybe lower down your memory speed first and before you apply those timings. vCore 1.41, previously had 1.39. I slightly increased this in order to maybe run 5.1. Memory voltage is also fairly high, 1.76, 1.55 is stock for this kit, which is already quite high, but that's still okay for the CPUs. 1.76 should also work. Obviously there's always a risk involved, but yeah, we're going to talk about that in a second. VCCIO 2 and System Agent also had to be slightly increased for the CPU to be able to run higher memory speeds on the IMC. If we keep in mind that those settings are stable for daily use, that's quite impressive. 66,000 read, 63,000 write, 60,000 for copy, and below 50 nanoseconds for latency. It's really quite awesome. End result in Cinebench R20 with a tweaked memory and also tweaked CPU, we can reach 6400 points in R20 with 5.1 GHz and 4400 C14 on the memory. And just for your reference, this is a result you would typically get with like a 3200 C18 kit, which is just an average memory kit. It's not the slowest, but it's just very, very average. And we are about 20,000 megabytes behind in read and write, and also the latency is much slower. In Cinebench R20, it's not that easy to show such differences between memory kits, especially if you're not running the CPU that much on the edge, and especially if you're also not running a very tweaked OS. Then you also have a certain like fluctuation between the runs, and then it's not that easy to tell a big difference within the runs from going from a very tight memory kit to like an average memory kit. While the test results are quite impressive, especially with those extremely binned DDR4 kits from G.Skill, it takes a lot of time, obviously, to prepare such setups and also test every memory configuration. That was obviously not done today within 1 hour, so it was several days of testing. And actually, all those results and preparation were done with a different CPU. It was done with this CPU. And I mean, it's written in German, but the CPU is dead. And that's something that just happens. I can just tell you that in what condition the CPU was running while it was dying, but it's not unusually high, I would say. I mean, vCore was 1.37 volt, which is fairly normal. I mean, that's a vCore you're also seeing on Auto. VCCIO and SA were quite high, 1.6 volt. But that's still in a region where you could say for testing, that's still okay if your temperatures are all right. Typically for 24/7 I would set the max to 1.45 for I/O and SA voltages, so we are rather high in those. VDIM was 1.76, but that shouldn't be the impact or the reason why the CPU is dead. Also, just because VCC/I/O and SA are 1.6 volt and it's a high voltage, it doesn't mean that the CPU died because of the voltages. It could also be that the CPU had an issue in the first place and it just died in right that moment, like this was the final thing to kill it. That's always something you have to keep in mind. Just because one single CPU died in one certain situation, you can never tell what exactly the reason was for the death of the CPU. But that's something that just happens. Luckily, I mean, I'm just going to be fully open, fully honest. That's the CPU I got for launch from Intel, so I didn't pay for it, so it doesn't hurt me that much. It just things that happen if you're like a reviewer, if you're testing a lot, then sometimes things just die. I mean, that's what happens, and could be worse. That's why we did everything again with the 11900 KF and not the K, but all of that was also fine. Apart from that, the Tachyon board is a great board. Like just from how it works with retry and just debugging, everything was beautiful. I absolutely enjoyed it. Seems like she also enjoyed it. Right, but the last thing I want to test is a gaming scenario, because right now the temperatures were not that special, not that great. Seems like she is dropping something off the table again. Anyway, regarding temperatures, because we're also using the EK Tech CPU water block, the reason why we're not seeing the best CPU temperatures ever might also be related to the fact that I'm only using a 360 radiator, which is not the biggest surface area, especially considering that we already have a 300 watt power draw from the CPU itself. And you have to add up the tech power draw on top, right? So it's maybe a bit much power draw for only a 360 radiator, and I was actually planning to run this with a Mora from Watercool, but to be honest, I forgot to order it. So we might have to repeat that if you're interested. Otherwise, I'm just going to change the VGA, going to change it to some RTX 30 series card to put some more load on the CPU, and then we're going to check out some performance data and also temperature data in a gaming scenario. By the way, right here I have an example, like the perfect example situation why the retry button is also a very nice feature. So I was running Cinebench and I was doing some further testing, and as you can see, it was completely unstable. Right when I pressed start button on Cinebench, it immediately froze. Well, I actually just had the same situation before, and then reset wouldn't work anymore because it was such a hard lock that even reset wouldn't work anymore, and then I had to press retry and then it was working now. Obviously, it just rebooted. Thanks. For the perfect harmony within our system, we already had the first product with trashy cable management, and then we have the second product with also garbage cable management. 3080 Ti. Still hate this connector right here. So yeah, I already thought that this could be an issue because 3080 Ti overclocked manually 11900K with tech cooler. And right here, I'm running a Seasonic 850 watt PSU, which is a great PSU. I've been using this for a very long time, also for a lot of my testing, but 850 watts, I already thought that this could be on the limit. Bye PSU. So a gentle upgrade to AX1600i, that should be sufficient for everything what you're running. One more thing I would like to add is you could probably see already that I added a fan on the memory modules. Because already yesterday when I did my testing, I figured out that running 4400C14 at a very high memory voltage, at a certain point the memory modules are getting quite warm. And whenever they're getting too warm, the system gets unstable. So if you add the fan and they're sitting probably at like, I don't know, 35, 40 degrees Celsius, everything is fine. But without the fan, at a certain temperature, it will become unstable. As you can see, I'm running some gaming benchmark, well, PUBG right now, just PUBG Arcade, to get you some ideas of temperature and also the possibilities of the cryo cooler, because if you pay closer attention to the CPU, you will see that the CPU is staying very cold with the cryo cooler, somewhere between like 45 and 50 degrees Celsius. And that allowed the CPU to also run a higher frequency. We can now run 5.2 gigahertz, whereas with the very high load of Cinebench R20, we could only run 5.1 gigahertz. Both the Tachyon and also the G.Skill memory kit are both very impressive when it just comes to the raw performance and also how they react. It's very fun to play with those components, especially the board is great. I really cannot complain about it. It's a lot of fun to play with the board. The features are awesome. But those are also features I personally would never put such a mainboard in like a 24/7 system, even though you could definitely do it and probably tweak your system like 1% better than with some of the other high-end boards, but then it's still kind of a waste to put the board with such impressive features inside a 24/7 system. Same goes to kind of the cryo cooler. The cryo cooler to me is a fun tool to play with. Like at the weekend, if you're trying to do some benchmarks, for example, you want to do, I don't know, single core validation, 32M runs, which is also just a single threaded load, then it might make sense to use such a cooler which can maintain lower temperatures than what you would be able to achieve with a normal custom water cooling loop. At the same time, if you're running a very strong custom water cooling loop with like a Mora, I don't know, 9 120mm fans, then for multi-core and very heavy loads, you might be able to achieve better temperatures than with the cryo cooler, because at a certain, I don't know, load above 300 watt, the cryo cooler is not capable of dissipating the heat anymore of like 11900K. The heat output of the CPU will simply be too high, and in that case it might make more sense to just run a very strong custom water cooling loop. Otherwise, like for lighter loads, gaming scenarios, you could use it. Personally, to me, the power consumption for a daily use would be too high. I don't see how it would be justified to run 100 megahertz higher and at the same time have a constant higher power draw between 50 and 150 watt. To me personally, that would be just too much. For the memory kit, it's also very impressive, but it's also very expensive. It's basically the same thing. You can run 4400 C14, which is very tight and very, very fast. But at the same time, as I said before, when I checked this kit like 2 or 3 weeks ago when I got it, it was about 500 euro. And for 32 gigabyte, that is a hefty price. And you will have to think about if it's really worth to invest in such components, especially for daily use. I mean, if it's for benching, I can totally justify it. I can totally understand that you would get everything that is right on the edge and what gives you the best performance. If you're participating in competitions and stuff, absolutely not gonna argue about anything. For 24/7, I would probably not get any of these components simply because the price is too high. You can get very similar components. Well, you can get very good components also for like half the price, which will be also decent for 24/7. But those would be like the ultimate components you can get for C590. So if you're looking for that, that's probably the recommendation. All right, thanks for tuning in. See you next time. Bye-bye.